Hi everyone, welcome back to Coding Concepts. Today we're going to talk about reference types versus value types. So in high-level languages, value types are variables that are on the stack, and they usually contain an offset to stack memory. So a common simpler explanation people use is value types hold the value, which isn't technically true because everything is a memory address generally in programming. It just, in high-level languages, it will just convert it to the value for you. You don't need to do it yourself. Reference types are variables on the heap. Generally, they contain the memory address to the heap memory. Watch my video on the stack and the heap if you don't know what those are. When is something a value or a reference type? It depends on the language. So here's a list of some high-level languages. So C#, int, float, bool, struct are value types. Class, string, array, list are reference types. Java is very similar, except there's no structs. Python, everything is a reference type. It works a bit differently. It's not as simple as that though. And then JavaScript has number, boolean, and class, array, and function. So for languages like C, C++, or Zig, with manual memory management, you choose when they are reference or value types. So why are they important to know about? It can completely change the function of your program. I'll show you. Here's a Java example. So here we create an integer, number, and we pass it to change value, and that changes the value. And then we create an array, and then pass that to change array value. And in both situations, we're just literally plussing 10. But what do you think this will output? Have a guess. So the output will actually be number is 10 and numbers is 20. Why? So integer is a value type. So when you pass it to a function, it will actually copy the value. So here this copies the value. And then we edit it, and that changes a copy of the value, not the original. So back in the main function, it's not changed. It doesn't do anything. Whereas an array is a reference type, meaning it's on the heap, and it's basically a memory address. So when you put that into a function, it's a memory address. So it will go to the original memory in the main function. That's why it changes. So you pass a single integer to a function, it will be a value type and be copied. If you pass a reference type, an array, a class, then it will send a reference to the original one and change the original one if you change it. Okay, so here's another example with a class. So it's just simply got an integer in it, that's all. First we do exactly the same as before. So we create a number, give it the value of 10. Then we create a number 2, give that the value of number, and then add 10. And then we'll check the result afterwards. Alternatively, we'll create a class and then have the class with an integer in it. And then we'll create a copy of that class, thing2, and then set it to thing. Have a guess what this will print out. So this will print out this. So number is 10, number 2 is 20. As it's not copying the reference. Basically, so we create number, we set it to 10, and we create number 2 and set it to number. It will copy the value and won't change the original number. So then we add 10 to number 2, and it doesn't change the original value, it changes the new value. It copies it for you. It's the opposite with a class. With a class, it's basically a reference type. So it's heap memory, and it's a reference. It's a pointer in lower level languages. It's a pointer to this. So when we set thing2 to thing, we're setting it to the pointer to the original memory. So if we edit the value of thing2.value, it will change the value of the original one as well. So they're both 20. I hope that makes sense. So if you want to change it so it will not change the original, we'll have to create a new thing. So here we create thing1 and then thing2. But we create with new thing, and then we change the value of that to the thing.value plus 10. And now this won't change the original value, and it will give you this, like exactly the same as the above numbers. So in Python, it's very weird and very different. Have a look at this example. So in Python, everything is an object. So everything will be on the heap. It does use caching in the, so it's not exactly like everything creates a new object, but anyway, so besides the point. So first we create A 10, and then we set B to A. And then we set the value of B to 20 after that. So what do you think that will print out? And then afterwards, we create a list, 1, 2, 3, and then we set the list, we create another list of Y and set it to X, and then we append with 4. So what do you think this will print out? Let's have a look. So it prints out 10, 20. So even though an integer is a reference type, not a value type, it still acts like a value type, because in Python they separate mutable from immutable reference types, which is a bit weird. So basically, if it's in this list, so immutable types are int, string, float, tuple. If it's one of those, then when you copy it, it just takes the value. It doesn't basically use the memory address. So it'd be separate. It won't copy it. Whereas with a list, dictionary, or a set, it will use the memory address, if that makes sense, because it's mutable. So this is kind of weird, and Python isn't very simple when you actually look under the hood. And then finally, a C example. So in C, you do everything yourself. So in main, we create A and set it to 1, and then we call the function add1, which adds 1. But if you look in the signature of add1, it just says int. It doesn't say pointer to int, so it's not a reference type. It's a value type, so it copies it. So this means that A won't be changed in add1. It will only be changed in the function itself, not in the original main function. And then we add one pointer, and we send a reference to A to add pointer 1, and they're pointers. So we're changing the value of the pointer. So in C, if it's on the stack or if it's on the heap, it doesn't matter. You can create a reference type. It doesn't matter. So it's your choice. In higher level languages, it kind of does it for you, and you don't have much control. In C# you have a bit more control, but generally not. So look at the output of this. After add 1, it's 1. After add 1 pointer, it's 2. So in summary, a reference type is a variable with a memory address inside it. And a value type is actually the same thing, except for it copies the value for you. So you may as well just think of it as it contains the value anyway. So that was value types and reference types. Let me know if you have any questions. I'll see you guys next time.